So there's another important feature of the angular function that we need to take a look at. And so let's focus on the orbital px, okay? And so let's take a look at the function, the angular component for px, okay? Where the angular component for the px orbital is going to be equal to 1/2 root 3 over pi times y over r. Okay, oops. All right, and so similar to how we did some analysis of the mathematical function for both the one-dimensional particle box and for the radial component, we can try to find areas dictated by the mathematical function that where there will be no probability of finding an electron. And so if we look at this, what we see is that when y is equal to 0, the entire function becomes 0. And so the wave function becomes 0, and therefore the square of the wave function, which is the probability of finding an electron, also becomes 0. Okay, so that's at any point on the axis where y is equal to 0. And so what that means is that that's a plane instead of just a point. Okay, since we're in three-dimensional space, right? And so there's a plane that runs along, it's a YZ plane, at which there is a 0 probability of finding an electron. And so this is called a nodal plane. All right. So when we consider the radial function, right, we have different radii at which there's a 0 probability of finding electrons, so different radii away from the nucleus. But then also, depending on what whether this is an s orbital, a p orbital, or a d orbital, so on and so forth. So in other words, dependent on the quantum number L, we also have nodal planes to consider, where we do not expect, where we will not be able to find electron density. Okay.